Welcome to the next unit. This is Unit 2. We're going to be talking about functions and domains and ranges and all that good stuff. So I haven't had time to really grade your tests, so after we get through, after I grade them, I'll probably do a little review video for you on how you did. So this is going to start Unit 2, so this is starting your next test information. Okay, so in Unit 2 we're going to review, we're really reviewing, but we are going to talk about relations. Okay, a set of ordered pairs, okay, or table values can, as an expression of how you are going to maybe graph or plot your data. Okay, so ordered pairs Okay, so ordered pairs are, or a relation is a set of ordered pairs. Set of ordered pairs. You can put this in a table. Okay, you can put it in set notation. Okay, you can put it on a graph. Okay, anything like that. Okay, the set of x values is your domain. And the set of y values is called the range. Okay. Continuous is when it's would be in a straight line. Okay. So a function, okay, it's a relation where each element in the domain is mapped to one element in the range. Okay, so a function would be something like the set of ordered pairs 0, 1 for third, 2, 6, -2, I'm making up some numbers here, and 5, comma 7. So this would be considered a function because every x value is mapped to just one y value. Okay, so this would be an example of not a function here. So not a function if we had 0, 1, 6, -1, 6, -2, -3, 9. Okay, this would be not a function because 6 right there, your x value, is mapped to both -1 and 2. So this represents not a function. Okay. Also, you can look at a function by passing the vertical line test. Okay, so if you looked at a graph, so if you were to draw a graph here, I don't know, let's look at a linear equation as a straight line. Okay. A vertical line test is if you draw a straight line through the graph, okay, if you draw a straight line through the graph and it touches the graph in only one spot, then it's considered a function. Okay, so you will draw a vertical line through the graph. If that vertical line only touches the graph in one place, the graph represents a function. Okay. Okay. So here, if I was to draw, I don't know, a circle through here. Here's my x-axis, here's my y. If I was to draw a straight line through this graph right here, what's going to happen? Okay, if I draw a straight line, it's going to hit it and it's going to touch that graph, that circle, in two places. So this one can be considered not a function. Okay. Okay, so let's do some examples. Let's look at some examples here. So here are going to be some ordered pairs that are going to be set. Okay, so let's do this question here. So it's got a set of ordered pairs here. So -1, -9, 0, -5, 4, 3, and 6, -2. So the domain is going to be all the x values. So we've got -1, 0, 4, and 6. Okay, and my range then is going to be a -9, -5, 3, and 2. So is this a function? So -1 maps to -9. There's no other 1. 0 maps to -5. Every 1, so then this is yes. So every x value has a 1 y value. Okay? All right, here's another example of a relation here. So this is called mapping here. So here's your set of all x values. So your domain is going to be consisted of -4, -2, and a 5. And your range is going to be 0, 3, 7, and 9. And is this one a function? It's not, because 5 maps to both 7 and 9. So this is not a function. Okay? All right, let's look at this graph here. This graph, we can talk about domains and range. So this is a continuous graph here. It's going in both directions. So the domain here, it's going from -infinity to +infinity. I can plug in any type of x value that I want. So my domain is all real numbers. So you can say all real numbers, or you can just say the real numbers there. So whichever way. Okay, the range is then your y value, so it's going to keep going in both directions. So it's going in the negative y direction, and then it's going in the positive y direction. So this is all reals as well. It's a continuous graph, so it's going in both directions. So even if you drew a line straight through it, it only touches in one spot. So this answer there would be a yes. All right, let's look here at this next one. Okay, this next one is actually a square root equation. So the domain is going to be all the x values. So my x value is going to be everything greater than 0 right there. Because I have a stopping point right there. I don't have any negative values that are going to be on my graph. So x here is going to be everything greater than or equal to a 0. Okay, the range, I don't have any negative values either in either way. So I have all positive values, so that means that y is also going to be greater than or equal to a 0. Okay? Is this one a function? If you draw a line through it, the answer to that would be a yes. Okay? These next ones I'm going to graph in a graphing calculator. But I'm going to also talk about them if you don't have a graphing calculator. X squared plus 3 here, the domain there is all real numbers, okay, as well, and the range is going to have a stopping point. So the domain here is all real numbers. So anytime you have a quadratic, this is a quadratic equation, the domain is going to be all real numbers. Okay, so let's look about if we have a graphing calculator here. So if I type in x squared plus a 3, and I want to graph it, okay, if you see this right here, I can plug in any x value that I want to, so my domain is all real numbers, but my range, I'm going to have a stopping point right there. And if I need to go zoom in, I can zoom in and see, or I can even see the table values there. That table value is going to be when x is 0, y is 3. So it's going to be everything greater than 3. So let's go back to the graph. So that value right there is going to be a 3, y equals 3. So it's everything greater than a 3. So my y's have to be greater than or equal to a 3. And yes, if I drew a straight line through here, this one would be a function. So yes. Okay. All right, let's look at this next one here. So x equals a -1. So x equals a -1 means that it's going to be a straight vertical line through the x-axis. So my domain, what is my domain? My domain is just all x equals a -1. That's all it is. Only -1s there. The range is all real numbers because it's going to go through. So it's all real numbers. So it's everything from positive to negative infinity. And is this one a function? If I was to draw a straight line through it, it touches it in a lot of places. So no, this one is not a function. Okay? So that is our functions and our domains and our ranges and looking at functions. Okay? So now we're going to talk a little bit about evaluating functions. Okay? So evaluating functions. Okay, so a function just is an equation solved for y. Okay, except for now it's going to have this notation here. So, and what that means, that says a function f of x. Okay, so function f of x. Okay, so what we're doing is we're putting x is my input, and f of x is my output. Okay, if you're making tires, you're putting in, or I don't know, if you're, well, how about this? If you go to the vending machine, you put in money, and what you get is some food. So that's exactly a function. So you put something in, and you get something out of it. Okay, so that would be function notation. Okay. So when we evaluate a function notation, so if I had this function, 2x plus a 3, and I wanted to find f of -2, okay? What this means is I am going to replace, I'm going to put -2 in for my x. So instead of having an x in my function, I'm going to have a -2. So I'm going to have 2 times -2 plus a 3. So that'll be a -4 plus a 3, which is a -1. Okay. All right, let's do another one. Okay, so if I let f of x be -x squared plus a 9x minus a 1, and I wanted to find f of -2. So this means that I'm going to replace my x with a -2. So I'm going to have a negative times a -2 squared plus a 9 times a -2 minus a 1. So -2 squared is going to be a positive 4, but there's a negative on the outside, so it's going to stay negative. 9 times a -2 is a -18. So here I'm going to have a -23. So f of -2 is going to be equal to a -23. Okay, so what about this one? We've got let g of x equal 3x plus a 5 and find g of 5/3. So y'all try to do this one for me. Okay, so I'm going to have 3 times a 5/3 plus a 5. 3's are going to go away, so I'm going to be left with 5 plus a 5, which is a 10. So g of 5/3 is equal to a 10. Okay, so here I've got two functions. F of x is equal to -5x minus a 14. G of x is equal to -x squared. Okay, -x squared plus a 9x minus a 1. So I want to find f of 1 minus f of -4. Okay, so I'm going to plug in a 1. So f of 1 is going to be equal to -5 times 1 minus a 14. So it's a -5 minus a 14, which is a -19. F of -4 is equal to -5 times -4 minus a 14. So that's going to be a positive 20 minus a 14, which is going to be a 6. So now we're going to take -19 minus a 6 there. So -19 minus a 6 is going to be a -25. Okay? Okay, so let's do an example, kind of like a word problem with our functions. So Owen paid a landscaping company $108 for an initial lawn treatment, then $74 per month. So here's my function. P of M is equal to 108 plus 74 times M. So M is going to be equal to the months that every month that we got our long treatment. So the first one I want to do is find P of 24. So P of 24 means that I am going to be receiving long treatments 24 months, for 24 months. So P of 24 means I'm going to plug in 24 in for my M. Okay, so I would say what? 74 times 24 plus 108. So that's 1884. So that means $1,884 that you're going to pay over 12 months of service. Okay, so after 12 months of service, we will have paid $1,884. Okay? All right, let's look at this next one. So find how many months he received long care if he has paid $2,995 to date. That means until today. So I'm going to rewrite my function down here so that you can see it. Okay, so here I'm actually going to be solving for M. So I know how much I am receiving, so I know how much money I'm paying out. So I know the total, just like I did in that last problem. So that means this is going to be 2,994 is going to be equal to 108 plus 74M. Okay, so I'm going the backwards way here. So now this is an equation, so I'm going to subtract 108 on both sides here. So 2,994 minus 108 is going to be equal to 2,886. And then I'll divide both sides by 74. So 2,886 divided by 74 is going to be equal to 39. So it's been 39 months since the beginning from when I can pay. I've been paying $2,994. Okay? All right. So we're going to do a little bit, let's do one more thing here. So let's let f of x be negative 4x plus a 9. Find f of x plus 5. Okay, so here I have an x. I have f of x is equal to negative 4x plus a 9. But I want to find the function evaluated at x plus 5. So that means instead I am going to plug in an x plus 5 everywhere I see an x. So I'm going to have negative 4 times, now instead of just an x, I'm going to have an x plus a 5. Okay, so when I do this, I'm going to distribute. So this is going to be a negative 4x. Negative 4 times 5 is a negative 20. So you're going to have a negative 4x minus 11. Okay. All right, let's do one more. Okay, so here I want to let f of x equal x squared minus 5. And I want to find f of x plus 3. Okay, so that means that I'm going to plug in x plus 3 everywhere I see an x. So this means x plus 3 times x plus 3 minus 5. So you're going to distribute. So x times x gives me an x squared. Okay, x times negative 3 is a negative 3x. 3 times x is a positive 3x. 3 times 3 is a 9. Your middle term, I don't know why I just made that a negative there, but that's a positive. So combine like terms, so 3x plus 3x is a 6x, and 9 minus a 5 is a 4. So you're actually plugging in a function inside of another function, which we'll talk about a little bit later. But this is actually very interesting, and you will be using this later, especially in college algebra. Okay? All right, so I want y'all to try to finish that homework, and if you have any questions, please let me know. Y'all have a great day.